This is the expanded notation subtraction method. Looking at each of the numbers that I need to subtract, I notice that they have a value, that the 9 in the hundreds place has a value of 900, that the 1 in the tens place has a value of 10, that the 6 in the ones place has a value of 6. Likewise, the 4 in the hundreds place that we're subtracting has a value of 400, the 8 in the tens place has a value of 80, and the 7 in the ones place has a value of 7. Now that I'm thinking about the value of each of those numbers, I can subtract. I'm going to do that using one of these values at a time. The first thing I'm going to do is subtract the 400. And then I will cross it out to remind myself visually that I have subtracted that value. Now that I've subtracted the value 400, I'm going to subtract the value 80 and cross it out so I remember that I've subtracted it. Often when students look at the regrouping, which we know traditionally in the standard algorithm, they get confused. I'm going to suggest that you might want to skip the regrouping and think of subtracting the tens place from the hundreds and the tens place, 510 minus 80. Now I'm going to count backwards from 51 because counting up from 8 to 51 is going to take me some time. 50, 49, 48, 47, 46, 45, 44, 43. Last, I need to subtract the 7. That is the last value. And as I did up here, I'm going to avoid worrying about regrouping by taking the value of the tens and ones place, 36, and subtracting 7. I'm going to do that by starting at 36 and counting back 7. 35, 34, 33, 32, 31, 30, 29. Now, when I have fully subtracted 916 minus 487, my answer is 429. If you're not certain or you're not comfortable assuming that your answer is right, you can check it using addition. If the number that you come up with in your addition problem, 916, matches your original number, 916, that you were going to subtract 487 from, then obviously your answer of 429 is correct. This again has been expanded notation subtraction method.